Okay, so here you go. What is this?
H2CO3. The acid.
The acid. What's the name for it, by the way?
H2CO3.
Carbonic acid. That's the one. So what we're going to talk about today is what happens if, are y'all ready? Are y'all ready? Come on. What happens if we take this, which is an acid, like you said, and then we combine it together with this? Do you know what this is? Do you know what this is called? What's Na?
Oh, that's my name.
Sodium. What's this?
Oxygen, hydrogen.
Oxygen, hydrogen. What do you call that? It's an ion. It's on your ion list. Do you know? I did not spell your name wrong. I wasn't trying to write your name, Noah. Do you spell your name with a capital O and a capital H?
No, that's why it's wrong.
Will we go in OH?
I'm so sorry that I'm not trying to write your name. What is OH? It is kind of cool that it's similar though, isn't it? What is OH? It is oxygen and hydrogen, but what is the name for that ion? You should be looking at your ion list. What? Hydroxide. So this right here is called sodium hydroxide. Do we know what kind of molecule this is?
It's probably a base.
It's probably a base. What makes you say that? Not because there's a carbon in it. It's actually a base because it has this OH in it. Now, there would technically be more complicated versions of that answer, depending on how much chemistry the person knows that you're talking to. But the short version is that anything that has an OH in it is a base, and anything that has an H at the front of it like that is a acid. Okay? So, what is the pH of acids, high or low? Acids.
Low.
Low. The pH of acids is low. What's the pH of bases?
High.
High. So what do you think you get if you combine them together?
Medium.
Medium, which is, starts with an N.
Neutral.
Neutral. Right? What is the pH of plain water?
7-ish?
7. Yeah. All right? So, now, here's what we're going to do. Watch this. Watch this. We're going to take it. We're going to add it together. And then we're going to let them have a chemical reaction. Do you know what they're going to do? They're going to do a double replacement reaction. Are you ready? Are you ready for the double replacement reaction here?
Yeah.
All right, so watch. This one's a little bit special. This right here and this right here are going to switch places. Okay? Now, watch what happens. Let's do it together. Are you ready? Here's 3 O's. Bye. There's a C. Okay? And there's 2 H's. Do you see what I just made right there?
A flower.
It does look like a flower. But what did I make? Which one?
Oh. Wait. You made the second.
Which one did I make, y'all? Come on, figure this out. This is not a hard question.
Carbonic acid.
I made carbonic acid. See, it has 2 H's because they're blue, and the carbon that's orange, and 3 pink oxygens.
Yeah.
Okay?
Oh, got it.
And now here's my Na. Okay? And here's my OH. Look good? You like that?
That looks yum.
Okay? So we're going to take this OH, okay, and this CO3, and we're going to swap them places. Okay? Now, we've got a problem. Do you know what is the charge on carbonate?
Is it?
Look it up if you don't know. Look it up. Find it. Somebody find it.
-1.
Look it up, look it up.
It's just a negative.
It's not just a negative. Carbonate.
Oh, carbon.
Find carbonate.
-2.
It is -2. If you're not sure how I found that, the answer is it's in your list. You just gotta look it up. All right? What is the charge of OH? Hydroxide.
That's -1.
This is -1. Okay, now, if we just flip-flop those, are the charges going to be balancing out to be equally neutral?
No.
No. We can't have a molecule that's not neutral. So this is what we have to do. Instead of just flip-flopping them like we did, we have to add another NaOH. Here it is, okay? Because that way, here, let's undo the flip-flop, okay? We'll undo the flip-flop for a second. Okay? If we add another one, then watch what happens. Are you ready? Are you just watching? Don't try to write anything, just watch me, okay? So we're gonna flip-flop the OHs. We're just gonna put the NAs together. And we're gonna take these and flip these over to here. Okay? And put these all together. I'm gonna keep the one with the writing over here just to make it easier. Okay, now, what do you see here?
What is that? H4?
Do you know a molecule that's what is it? H 1, 2, 3, 4, O2? No.
Yes.
But does that look kind of like something else that you know of?
Yes.
What does it look like?
H2O.
Could we just divide them up a little bit?
Yeah.
Look at here. H2O, H2O, we got two of them. Do you realize what happened there? So here you go. We made H2O, and we also made, what is this one? Na2CO3. Right?
Yeah.
All right, but there's one other really, really important thing that we have to do right here, which is, how many waters did we make?
2.
Come on, y'all. I want to hear more than just one person answer that. How many waters did we make?
2.
2. So put a 2 in front of it. And how many NaOHs did we have to start with in order to do that? 2. Does that make sense?
Absolutely.
All right. I'm going to unmake it again just so we can watch it happen one more time. Got it? All right, so here we go. We start out with a sodium hydroxide and another sodium hydroxide and an H2CO3, right? So we're going to do a double replacement reaction, which means that we switch their partners. So the NAs are going to go over here, and the CO3 is going to come over here, okay? And then one of the hydrogens can go with each of these. Do you see what we just did there?
Yeah.
Is that kind of cool?
That's pretty dope.
All right. Now, here's a question for you. I'm going to undo it one more time. So if it would help you to see it undone one more time, we can do that, okay? Now, trick question. Are you ready?
Okay.
What would happen if I had this?
You just made 3.
I've got 3 of them now. What would happen? Can I do anything different? Look, I take a NA, scoot these over here. How many NAs have to go with the carbonate? 2. Why do they have to go that way in that number? What's the charge on Na? What's the charge on Na?
It says 1.
1. How do we know it's 1?
Because it's in the 1 column.
Because it's in the 1 column, right? Meaning it has 1 electron in its outer shell that it wants to get rid of, right? So this is a charge of 1. This is a charge of 2. So you have to have 2 with 1. You have to. So if we take this over here and go, okay, now, if you want to make water, you can't make it any other way than H2O, right? So this one comes over here. Please don't make H3O. That's not good stuff. It's radioactive, actually. Okay. If you do that, what happened to this guy down here?
We just ignored it.
We just ignored it. I know. Sad stuff, right? So, get your Chromebooks ready. Get your Chromebooks open. I'm going to show you something. All right. So the last thing we're going to add on here, I'm adding directly onto your other notes. And we're going to talk about something called balancing chemical.
Yeah, I got this fast.
Thank you.
It's from Miss Major.
Reactions. Okay. So now before I kind of go into this a little bit more, I want to give you a couple of little things about this. I gotta use different color. When you have a chemical reaction like this one, or like any one, there's a name for these compounds right here. You might know what it is.
I'm naming it. Reaction.
The whole thing is a reaction.
Reactant.
Yeah, reactant. Well, reactants, because there's 2 of them. And then this one over here is called product. Okay? These numbers here at the front have the same name as they do in math class. Do you know what that is? Start with a C.
Covalent. Coefficient.
Coefficient.
Dang.
Okay?
It's like made backwards.
Am I skipping something here? I am. This should be CIENT. Okay, I skipped the C. Okay? And then these numbers right here, the little ones, are called subscripts. Can you see why?
Because they're subbing scripts.
What does sub mean?
That means to replace.
But substitute, submarine,
Down.
subway,
To go?
Under.
under.
Subway surfers.
Substitute. How does that mean under?
Well, because you have less authority than the real teacher does, the main teacher, right? The same amount of authority in terms of y'all better behave yourselves and mind your P's and Q's and so forth, but in terms of assigning the work and so forth, it's different, right? That's why it has that word. So, balancing chemical reactions. There we go. So, a few things about this, okay? The first thing that's most important is that mass must be conserved. Do you know what that means?
Yes.
What does it mean?
Saved. Where you cover it.
Saved. What is this famous thing that we've all heard before?
An object in motion state.
Can't be created or destroyed, yeah. Now, it's really easy just to say that, right? But what it means in this situation is that you must start and end with, do you know what? Yeah, the same, and even more than the same mass. I mean, it will be the same mass, but I'm going to write it this way. Number of, do you know?
Particles.
Yeah, particles, but even more specific than that. Each atom. Because just think about it. If you start out with 1 hydrogen and 1 oxygen, but then you end up with 2 oxygens, does it weigh the same as it did before? No, it doesn't. So you've got to start out with the same number of each atom. And that is why when we did this up here at the beginning, we talked about starting with one of these, and then we realized that in order to make this work properly, we had to start with 2 of these. And it would also therefore end with 2 of these, right? So same thing going on there. All right? In terms of how to do this, and then I'm going to kind of teach you how to do it, there are 2 main strategies. And really, kind of, they're actually technically the same thing. I'm going to only teach you one of them. I'm going to teach you the one that we call the RAP chart. Okay? Which stands for reactants, atoms, and products. All right, I'm going to teach you that one. But what you will very quickly probably be able to do for yourself is what's kind of the more mature way of doing things, which is called the trial and error method. Believe it or not, that's the fastest way to do these. Because what starts to happen is after you've done a few of these, then you start to kind of know, you like start to see the patterns, and then you can just do it in your head almost. But starting to do it with the RAP chart is really helpful because it helps you to organize your thinking and see how to do it. All right? So I have a worksheet for us to do together. You love worksheets? All right, so the first thing I'm going to do is I'm going to make a RAP chart. And now, unlike usual, when I normally write with markers for you guys, I'm going to mark with a pen this time, just because this space is kind of small for writing with markers. So here's my RAP chart. Are you ready? Okay. Can you see that clearly enough? If you can't see it well enough, then scoot forward. Okay. All right, so here we go. The first thing we're going to do is we're going to list the atoms that are in this reaction. So what do we have over here? Al. What is that? I heard it. Aluminum. And then what do we have next? H. What element is that? Hydrogen. And then this one right here is a little bit of a trick this time. What element is this, by the way? S. Sulfur. And O is oxygen. But I want you to notice something. Do you notice that this is, do you know what this is actually? All that together? If you don't know what it's called, do you at least know where to go to find it?
Yeah.
Where do you go to find it?
Our thingy sheet.
On your little list of ions, right? And if you go there, you'll find that it's called sulfate, okay? But here's what I want you to notice. Are you looking up here?
Yeah.
Do you see that there's sulfate here and there's also sulfate right here? Okay? So since they stay together, this doesn't work if they come apart, okay? But if it stays together like that, then you can actually count the whole thing together as one atom. Okay? You'll see why in just a second. Okay? So here we go. The very next step is just to count. How many aluminums do we have over here? 1. Do you see that it's just 1? Don't overthink anything here. How many aluminums do we have over here? 2. You see that? It's right there. It's right after it. By the way, these on this worksheet, those should be subscripts, but in the creation of this worksheet, some copy pasting and formatting losing probably happened. All right, what about hydrogen? How many hydrogens do we have over here on the reactant side? 2. And how many on the product side?
2.
Also 2. How many sulfates do we have?
1.
4. The 4 goes with the oxygen, right? Because this whole thing means 1 sulfur and then 4 oxygens like that, right? So the whole thing, we have just 1 of those. And then how many do we have over here?
1.
Look carefully.
3.
3. You see that right there? All right, so a little bit of advice to you. There are a lot of different ways to go about figuring this one out. There are some smarter ways and there are some slightly longer ways. All of them will eventually get you the right answer. But just a suggestion for you. Start off by changing the elements that are not by themselves. Okay, so like when I see aluminum right here all by itself, I'm going to not change that one until the very end. I'm going to first start changing these two because they're like stuff combined with other stuff. Okay, because it just works out easier that way. If you want to change the aluminums right off the bat, I mean, go for it. More power to you. But just start with the ones that have stuff together, and you'll find it a little easier. All right, so let's look at the hydrogens. There's 2 hydrogens, but the sulfates do not agree. So I need to do something to change this to be 3. How can I do that? I can add 2, but I already have 1. So what number do I need to put in the blank up here? 3. Does that make sense? See what I did there? But when I change this to 3, what else also changed? Just the sulfate? No. What else changed? Not well. Yeah, but this sulfate is all together, so I don't have to worry about that. What about the hydrogen? Did it change?
No.
This 3 is like distribution in math. It goes to all of it. Do you see that? Okay. So 3 times the 2 hydrogens that there are now. How many hydrogens are now over here total? It's not 2 anymore because I added some more. What is it? 3 times 2, y'all. Come on. 6. Okay. Now, I think I just made the hydrogens not be equal because it was 2 and 2, but now it's 6 and 2. Can I change this over here so that I have the right number of hydrogens? What do I have to do? Put a 3 in there. When I do that, then this changes to be a 6, but nothing else changes. Only the hydrogen changed. Do you see how that's helpful to change the things that are together first? Because then I can change this one without switching anything else up. And then now I can change the aluminum, and I need this to be 2. So I'm going to say 2 there and put a 2 up there. Does that make sense? Do you want me to do one more?
Yeah.
Okay. So if you think you've got it, then go ahead. But I'm going to go ahead and work on the next one also. So first step is to make my wrap chart. I have iron, and I have O, and I have C. And I have 2 irons because there's a 2 after it. And over here I just have 1 iron because there's nothing with it. And here I have 3 oxygens. And over here I have 2 oxygens. Here I have 1 carbon and 1 carbon. Okay. So then let's see here. The carbons seem like they're okay. The oxygens are not okay. Another little trick on this one is that I see that there's an odd number of oxygens on one side and an even number on the other side. So in order for these to ever be equal, it's going to have to be an even number. Remember learning about like least common multiples in math class? Okay. So the only way to do that is if I multiply this one times 3, because 3 times 2 is 6. And then this one, I'm going to have to make this one be like times 2. So that 2 times 3 is also 6. Okay? But then when I did that, this one changed to be 3 carbons. And this one changed to be now 4 irons. Okay, so now I have to let's do the irons next. So there's 4 irons here and only 1 here. Oh, but look, I can just put a 4 there and it will fix the whole thing. And same thing with carbons. Since it's by itself, I can change this one, but I want it to be 3, so I want to have 3 of them. Does that make sense?
Yeah.
All right. on Canvas is this worksheet, and it's just the same as usual. There's an answer key at the end of it, so you can check.